when I want to perform insertion in heap, so what do I do? Supposedly I already have a heap. I'm having a given heap that I'm having 15, 13, 9. There are a few elements given, and if I am going to construct a heap out of them, so how can I construct a heap? I will simply be writing the elements at position 1, 2, 3, 4, 5, 6, 7, then continuing. जैसे जैसे order में elements है, this is already in the form of a heap. So every parent is greater than child. This is holding the property of the heap automatically, right? So this is already given heap to you with some 12 elements in the heap size. Now supposedly I want to insert 10 in this heap. How do I insert? Or any element, I'm just taking, I want to insert 10. So the key that is to be inserted is 10. Okay. For inserting an element, what I do is I increase the heap size. So I increase the heap size to the 13th element, and in the 13th element I store a minus infinity. After storing the minus infinity, I call a function called as heap increase key. What am I doing in heap increase key? I am putting the key in the correct position. How do I put the key in the correct position? We'll see. So what am I doing is, I first of all am checking that whatever the value is, this value should be less than a of I. So I is initially the heap size, which is 13, and key which I want to insert would be something greater than minus infinity. So I am beginning with the position which is at the last, जो हमारी heap size है. Initially I is 13, which is heap size, whatever my heap size is, plus 1. I have increased the heap size. Okay. Initially I is 13. I check k should be less than a of I. Oh, sorry. This condition should not be true. If k is less than a of I, then nothing can be done, but it will rarely happen because I have chosen a of I to be minus infinity. So whatever k is, that would be greater only. It would not be less than. So this condition we will check, this would not be true. After checking this condition, what I do is I simply substitute a of I becomes the new key. तो मैंने new key को 10 को यहाँ पे copy कर दिया. After copying the new key over here, I run a loop while I is greater than 1, and I check now if the parent of whatever I have inserted, अगर उसका parent छोटा है तो swap these two. That is, and I'm saying and if a of parent of I, जो भी parent of I की value है, अगर उसका a, this is less than a of I, that means parent should not be less than, the condition is not held. In this case, what should be done? In this case, I am going to exchange a of I with a of parent, and I update the value of I to be parent of, with the value of parent of I, so that I recheck the condition, I rerun the loop. This is all I do. That is all I will be doing. Itne mein I will be able to insert. Now let us see what is happening. I is 13, key is 10. Now here I am checking I is greater than 1, I is 13 initially. A of I में हमने 10 डाल दिए. Now A of parent of I, parent of 13, parent of any I, if you recall, parent of any I is I by 2 की floor value. So if currently I is 13, so parent of 13 is 13 by 2, which is 6 point something. So it is 6 would be the parent. So 6 is the parent for 10. Now I am checking A of 6 is less than A of I. A of 6 is 8. 8 less than 10 is true. Continue with the loop. I is all greater than 1 only. Exchange 8 and 10 because parent has to be greater. So you exchange the positions here. And now move I to the parent of I so that I comes here. I becomes, instead of 13, I now becomes 6 in the next iteration of the loop. Again check I is still greater than 1. Again check if parent of, now अब 6 का parent क्या हो जाएगा? I will have to do 6 by 2, so that parent of 10 I am checking. Parent of 10 is at 3, third location. So check if parent of I still 9 is less than 10, then again do the swap. If 9 is still less than 10, then max heap, the max heap condition is not held true again. So what should I do is, again the condition is true, exchange these two. Since I am going to exchange these two, 10 comes here, 9 comes here, and update the value of I becomes 3 after this exchange. I again calculate the parent of 3. Parent of 3 comes out to be 1. I again check I is greater than 1, 3 is greater than 1 is true. Parent of I now is 15. 15 less than 10 is not true. Come out of the loop. This is my final heap. I have done insertion. So what I do is, after putting a dummy key, I keep on increasing the key to its correct position. This is what the insert heap procedure is. There is a code that I am having is heap increase key मतलब key को increase करना है उसकी सही position पे. And the inputs to this, there are 3 inputs, a, I and key. 3 parameters हैं इस function में. Now what the function is doing, if k is less than a of I, जो कि initially नहीं होगा इसीलिए हमने a of I को minus infinity लिया है. If this is true, then print new key is smaller. तो हम insert नहीं करेंगे. ऐसा possible नहीं है. I'm again saying, since we are taking minus infinity, and I'll do nothing here. Otherwise, what I do is, a of I में I will be copying the key. After copying, I'll be running the loop while I greater than 1, while I is greater than 1, and a of parent of I. मुझे चेक क्या करना है, जो नई की मैंने अब नई की I have inserted at a of I am checking that the new key that has been inserted वो अपने parent से छोटी होनी चाहिए, तब तो heap की condition satisfied है, otherwise नहीं है. So if parent is less than a of I, that means I need to take some action. The condition of heap is not met. If this is the case, then what should I do is, I should exchange a of I with a of parent of I. And after exchanging these two, I should update the value of I. Since it's a loop, I have to change the loop variable. I have to update the value of I to be parent of I. This is all I do in heap increase key. Now I am saying this is not the insert key, this is increase key. अब जब हम insert key call कर रहे हैं, this is supposedly some max insert. Max heap में insertion चल रही है इसलिए मैंने max लिखा है. Max insert in heap. I am having some a and some key to be inserted. A is the heap, key मुझे insert करनी है, ठीक है? This procedure ends here. So first of all, I need to change the heap size. Insertion होनी है, तो सबसे पहला काम क्या है? We update the heap size to be heap size plus 1. I am updating the heap size. Then at the new location, I am putting a value of minus infinity, so that this k will be less than minus infinity. ये condition कभी true नहीं होगी. And I am calling heap increase key on a. Now I here is I जो मैं pass कर रही हूँ, that is heap size of a. Update हुआ हुआ heap size of a and key I am passing, that is to be inserted. That's it. This is the code. So these are the two codes. अब एक की को एक लेवल से ऊपर लेवल मैक्सिमम कितने लेवल्स अब जा सकती है? Till the from the lowest till the highest level only the insertion can take. So the maximum type this while loop will take, because I is changing to parent of I. The worst case में it will go from the root till from the last node to the first node. In any case अगर ऐसा होगा तो भी it is going to take of the order log n time. Worst case, maybe it is going to take of the order log n time for insertion. Let us see how. Let us take one more example and let us see how insertion is happening. So let me take another heap for you all. So I'm having a heap. Supposedly there is a 10. I'm taking some 4, 8. Just taking a sample example. Sorry, 5 cannot be here. 1 is there. A 0 is here. So supposedly I want to insert a 5. I want to insert a key 5. Now please see that the height of this heap, currently the size is 1, 2, 3, 4, 5, 6, 7. So the heap size currently is 7. I am calling max insert key, heap on this A, and I am calling it for key is now 5. Heap size, which is initially 7, gets updated to 7 plus 1, matlab heap size is now 8. So that I have a dummy over here जो भी create करेंगे. Okay. So heap increase key is called for A, heap size and key. So this is called for A. Heap size is now 8. बढ़ गया है. And key that I have to insert is 5. Now again I have put heap size of A पे I have put a minus infinity. So I have put this minus infinity here at the 8th position. I have put the minus infinity here. Now I am checking k, that is 5 is less than, this is key. Key less than a of 5 less than infinity is minus infinity is not true. So this is not true. I'll come here. A of I is replaced with whatever key I want to pick. So I put 5 initially here. So I'm initially inserting the key in whatever the next possible position is. Now after inserting this key over here, I have to move this key to its right location. We are not going to take any other garbage value because we are what we are trying to do is initially we are assuming that the heap was existing with lower values only. So possible lower values we are taking minus infinity. So whatever we are trying to insert, वो at least इस position पे तो insert हो ही जाए. So whatever we will be inserting will be greater than minus infinity in any case. So we insert here. After inserting, I have to position the key, increase the key to its correct location. कितनी locations लग सकती है increasing में? 1, 2, 3 maximum. So log n time is the maximum time this while loop can take. Let us see how now. Now a of I is key. While I greater than 1, now I is 8. I is 8. Key is 5. Okay. Now I am checking I greater than 1 is true. This is true. Now parent of I, when I am calculating parent of 8, it is 8 by 2, it becomes 4. So 4 is the parent of 8. A of 8 is 4. Now, sorry, is A of parent of I, A of 4, the value is 1. The value of A of 4 is 1. Now I am checking, is this 1 less than 5? A of I, जो कि हमने की insert कर दी. Yes, it is true. That means run the loop. Loop में क्या करना है? Exchange these two. Exchange. So I am going to exchange these two. I exchange 1 and 5. So that my new heap will be, I will be getting the heap to be 5 comes here now. This is the rest remains the same. Nothing else has changed. And 1 comes here. I again have to see whether this is the correct position or not. So I rerun the loop. I now update I to be the parent of I so that I is no more 8. It becomes 4 now. I still check whether I is greater than 1. Yes, it is greater than 1. Now again check A of parent of I. This time it is parent of I is parent of 4. 4 by 2 is 2. So A of 2, this value is 4. I am checking is 4 less than 5. Yes, 4 is still less than 5. Heap की condition नहीं satisfied है. Again I need to swap. I need to swap these two so that I get a 5 over here and a 4 over here. I am again swapping. Now again I changes, I becomes 2. I is still greater than 1. Again check parent of I, this time is 1. A of 1 is 10, 10 is less than 5, no. Come out of the loop, this becomes my final heap. All the nodes satisfy the property 10, 5 or 8 से बड़ा है. 5 is greater than 4 and 0, 4 is greater than 1, 8 is greater than 6 and 3, max heap property satisfied. I have inserted successfully in a heap in maximum possible log n time. Only maximum 3 times the comparison will happen and exchange will happen. So the worst case complexity of inserting a key into a heap is of the order log n. Is this clear to all of you? We are inserting now. We can insert anywhere in between. अब अगर हम कहीं बीच में insert करेंगे तो उस key का कहाँ, अगर मुझे यहाँ insert करना है, I know कि 5 has to be inserted here. How do I replace the 4? कहीं तो 4 को ले जाना पड़ेगा ना insertion के लिए. इसलिए what we do is we insert the key in the next probable position. जो भी next probable position है heap की उसमें insert करा. Then we increase the key to its correct level. By swapping, we increase the key to its correct level. 5 insert करा, 5 और 1 को swap करा. 5 और 1 को swap करने के बाद 5 और 4 को swap करा और increment करने की जरूरत नहीं है. That is what we do. Simple procedure. Insert where अब supposedly this is my new heap. I have a 5 here, 4 here and here 1. अब ये मेरी heap बन गई. Now supposedly I want to insert another key here. I want to insert some 12 just for example. I am intentionally taking 12 क्योंकि वो top level पे जाएगा. If I want to insert here, insertion will normally happen on the next possible thing. तो यहाँ पे A of 5 में 12 insert होगा. Then since 12 is greater than 4, I will be swapping these two. So 12 will come here, 4 will come here. This will be replaced by 4. This is replaced by 12. Again 12 is greater than 5. Again do the swap. 12 comes here, 5 comes here. Again 12 is greater than 10. Do the swap. 10 comes here, 12 comes here. After so many swaps, you have increased the key to its correct level. This is not a recursive function. It is a simple loop. You can call exchange in recursive function also. You can write that procedure, but there is no need to do that. You can directly run the loop like this. You can call this increase part recursively, but there is no need over here. So what is happening is you insert a key in the next probable position and you like supposedly now this is the heap. If I want to insert some 11 over here, just for example. So the next position is here. Again 11 greater than 0, swap. Again 11 greater than 10, swap and get the position. This is how you are inserting any element into a heap. Insert at the next leaf and increase the key to its correct level. Is it clear how do we do insertion in a heap? Whatever key I want to delete, I just swap the key that is to be deleted with the last key in the heap. So I replace the key to be deleted with the last key in the heap, which is stored at heap size of 8. So I replace the key to be deleted with this. I reduce the heap size. I reduce the value of the heap size and I call max heapify procedure. You all know the max heapify procedure already. So I'm going to call this max heapify on what? A comma I. Since I is the position for which I need to check whether the heap condition is holding true or not. That's it I need to do. Again, probability will come out to be of the order log n because max heapify calls itself, but maximum how many times it can call itself is again the height of the tree. So this comes out to be again of the order log n. If I am taking an example here, supposedly I take an example. I have a heap. So there is some heap and I want to delete some element within this heap. Supposedly this is a heap having 1, 2, 3, 4, 5, 6, 7, 8 and 9 elements are there. Now supposedly I want to delete an 8 from this list. So if I want to delete an element, what I do is I exchange the element to be deleted with the last element of the heap. Then I reduce the size of the heap and I call the heapify procedure for the deleted location. So what I do is, since I am calling delete heap for 8, 8 is at position 2. So I am calling delete heap for a comma 2. So a comma 2 is replaced with the last element. So this 8 gets replaced with 2. 8 is now deleted. I reduce the heap size so that this is no more a part of the heap. And I call heapify for this location. So if I am calling heapify for location 2, what will it do? It will check whether 2 is greater than 6 and 3. Since it is not greater, I will swap with the larger element so that the new heap will come out to be 12, 6, 2, 3, 0, 5, 4 and 1. After doing the swapping, again I will recall heapify procedure for the swapped. So I will be recalling heapify procedure for here. 2 के लिए दोबारा call होगा. 2 is greater than 0. No need to do anything. This is now heap and I have deleted the element. तो जो भी element delete करना है, supposedly from this I want to delete 12. That is the first element. So a of I is replaced by the last element. Again, I will replace this 12 by the last element. I replace it. After replacing, what happens? The new heap that comes out is 0 comes here. This is a 6, 5, 2, 3, 4, 1 and now I have reduced the size, so this will no more be an element, part of the heap nahi rahega. And I am calling heapify for the deleted location. So heapify for 1 is called here. Again I check 0, 6 and 5 which is the largest, and 6 is the largest and it is not the parent. A swap will happen. After swapping, 6 will come here and 0 will come here. Rest of the heap remains the same. Now again heapify will be called for the swap. जहाँ भी largest की location थी उसके लिए heapify is called. So the position of 0 again heapify is called. Largest is 3. They are swapped. So now the next condition of the heap will be 6 is here, 3 comes here, 2 and 0 are here, then we have a 5, 4 and 1. Again a heapify will be called for 0. It does not have any children, so it will come back. This is my final heap after deleting the element 12. This is how delete heap will go on. Whatever element I am deleting, I replace it with the last. Again till the last node, the max heapify will be recursively called. So the complexity of delete heap is again of the order log n. Insertion and deletion in a heap are now clear to all of you. Both of them are taking of the order log n time only.